Boom. Here we go. So there's your objectives again, just for those watching the video. Moving on. Actually, moving on that page over there. There we go. So, intensive properties. Who has watched the video on intensive and extensive properties? It's the super best way I could find to take something that takes 30 seconds to teach and make it take 10 minutes. You're all welcome. You need to watch those, by the way, because I will put them in your grade book, 4th hour. My grade book on your grade. Yeah, it's okay. Like, I'm not going to put a 0 yet, but I will eventually. So do the ed puzzles. In Canvas, you don't have to submit anything for that assignment. Not in Canvas, because I'll see the score on ed puzzle. It was just a link through Canvas. It was just a dumb way to do it. How about that? Okay. Here we go. Intensive properties are independent of the amount of the substance present. They are independent of the amount of the substance present. So like this yellow paper, whether there's 50 of them or 1 of them, they're still yellow, right? So the color of this paper is independent on how many there is, but the mass of these papers is dependent on how many there are. You okay with that? So independent things are like density, boiling point, and color. Most people, and this is in the video I went over this, most people do think density is dependent on how much of something that you have. But density, it doesn't, because it's a ratio of 2 things that do matter, and that cancels them out. And the example was that the density of 5 pennies would be the same as the density of 1 penny. All right? Because you're taking the change in mass and the change in volume, and they're being divided each time, and it just cancels out, so it doesn't matter. Oh, yeah. And I'm pretty slow and boring. I listen to books on tape at 2 times speed, sometimes 3 if it's a slow book. If it's the scriptures, definitely 3. But it's like ruined my ability to watch a YouTube video. I just get so frustrated. I'm like, spit it out. And YouTube, you can speed them up, but in my master's program, most of the videos you can't speed up, and I just lose it. So the ed puzzle, you probably wish you could speed me up, but it won't let you. All right. I'm sorry. I'm trying to be clear. And slowly. You're welcome. Okay. Extensive properties, they depend upon the amount of the substance present. All right. So mass, volume, energy, etc. Those are your extensive. A ratio, like density, typically will result in one that is not dependent, so it is extensive. Okay, so please watch those. Physical changes and chemical changes we sort of already talked about yesterday. Chemical properties, chemical changes, they're very, very similar, so they're not too hard. Physical changes are changes in matter that happen, but it doesn't change the substance. So for instance, and we did this yesterday on a little slide, but if I have a yellow piece of paper and I tear it in half, it still has all the properties of the yellow piece of paper. It's just in 2 pieces, right? So I physically changed it, but I didn't chemically change it. The other option would be chemical, is if I lit it on fire. Now a chemical change has happened because it's no longer paper. Easy enough. I did that once years ago. I lit it on fire, and then I realized I was holding on to it. And I just had to drop it in the sink. I'm like, what? I'm not very smart. All right. Chemical changes is what we care most about in this class, because this is AP what? Chemistry. So we'll study the reactions. These are just a couple of types of reactions: combustion, oxidation, decomposition, etc. You will learn all about these, so don't stress much about that yet. All right. I should have added this to our language objective for today. 2 words that you will use a lot in this class are products and reactants. So in every reaction, we start with things on the left side of an arrow, And we call those the reactants. And then they produce products. So the example that I just erased, just because it was kind of ugly, is when you take sodium and you react it with chlorine, it produces sodium chloride. These two things over here would be considered reactants, and the thing on the right side would be the product. This one is exothermic, so it gives off heat. Not every reaction gives off heat, but that one definitely gives off heat. Right, and that's called endothermic. Yeah, Liam? Yep. All right. Now, when I wrote that reaction, I put a little 2 next to chlorine. Will you remind your partner why chlorine had a little 2? That's the question. Nope. All right. Good. Thank you. So the reason chlorine has a 2 is because it's a diatomic atom. When it's alone, it's always with one of its twins. Remember that from yesterday? But sodium was not on that list, so this would be considered monatomic, meaning 1. This would be diatomic, which would mean 2. Now, I loved Jeff Agron gave a fantastic answer. We'll see. Why does chlorine not have a 2 this time? All right, because it's hanging out with someone else now. Well, I don't know how most of you feel, but if you have the chance to hang out with someone besides your family, usually you'll do it. Like most of us like to hang out with our friends except for post. You like your family better? Oh, you were agreeing? Okay, sorry. I thought that was it. Well, I really love my sister. All right. So, chlorine will only form a bond with itself if that's its only option. If it can find something else, especially a loser like sodium, it's going to hang out with sodium the whole time. And the number that would go here depends on what sodium is. And we'll learn that. You don't need to know that yet. But anyway, get used to that. Sometimes there's 2s because they're diatomic. Sometimes they're not there on the other side. Sometimes a 2 turns into a 3, but there's always reasons why, and you'll learn that. But for now, for sure, you need to know reactants are on the left, products on the right. Okay? All right, compounds, this is electrolysis. We talked about this yesterday. Compounds can be broken into more elemental particles, which is what we did. We took a compound called water, and we broke it down into its H's and its O's. And was that you that replied on Instagram? You're the only current student that did. The rest were like chemistry majors. They did a good job. I was proud of you. All right, this is the exact same thing we did yesterday, just with a way cheaper device. You just take a 9-volt battery, put the wires in. Is that me? I think that's me. Yep, that's my, that's the auto shop. Anyway, you just put those leads under here, collect that gas. You can do that at home if you have that stuff. Do not take a cord and just throw it into your tub, though. That's a super bad idea. All right, so compounds. Yeah, well, it'll ruin your whole house if you do it. Okay, the next thing we're going to talk about is separation of mixtures. And this is important because this goes with the lab that we're going to do tomorrow. We're going to start the lab tomorrow and finish it on Tuesday. You all right with that? All right. Now, the fire alarm might go off at any second. I think it's like 10 minutes, but you never really know. But just don't scream or pee your pants. All right. So here we go. Yeah, we'd have to shower. Maybe I'll go to the shower if there's a real fire. Be like, bring it. I'm ready. All right. The reason the reason we want to focus on this, so the AP test, and I'll say this a lot, and some of you aren't going to take it, but I just assume everyone does, and that everyone's goal is to pass it. The AP test has at least one really big question that's on labs. And you don't do a lab, but you read stuff, you look at all the data, and it's like you have done it. So we're going to do labs that are a lot like them. And this one's typically one that you'll see on the AP test, where it's just a separation of a mixture. So the first thing we need to know is what a mixture is. If you're a note taker, write this. If you're not, it's fine. A mixture is something physically, two or more substances physically blended together. Yes? Yeah, a ton. About 3 or 4 weeks before the AP test, we're done, and we just spend 3 or 4 weeks talking about the test. Yeah, not like Miller does, like where you actually have to sit here the whole time. But, well, sorry. Not happening. Not happening. Not happening. But we do a practice, but not organized like that. I would love to. A mixture is 2 or more physically blended substances, meaning they're just mixed. So you put sand and gravel together and you just stir it. Now you have a physical blend of sand and gravel. The main point there is it has nothing to do chemically at all. It's physically mixed together. So the way we separate a mixture uses physical processes. We separate a compound with chemicals, separate a mixture with physical processes. We all right with that? Thumbs up so far? Okay. In the lab, you're going to get a weigh boat. It'll be a lot smaller than this, but you'll get a weigh boat. And in that weigh boat, it's just going to have a sample of a mixture that contains 4 things. They are iron, citric acid, sugar, and chalk. And they're just all mixed together. Yep, so we're going to give you some tweezers. No. That would take you 1,000 years. All right. So our goal in this lab, and if you had normal chemistry, this lab is way easier because you already did it. Your goal is to find the percent of iron, citric acid, sugar, and chalk in the original mixture. So we're going to use the lab to separate the substances apart, and we're going to use our calculators to do the rest. You kind of all right with that idea? We're going to separate those using physical processes. And one of them is extremely easy to figure out how to get out. Any guesses? The iron with a magnet. Okay? To determine whether something magnetic, you don't change it, right? Put a magnet by it, and if it sticks, boom. If it doesn't, no. But did you change the substance? No. So you know it's a physical process. So we are going to take advantage of the physical property of whether it's magnetic or not. Oh. And we can use that to separate that out. The rest of them, we're going to use their solubility in other substances. Now, I'm going to give you a handout, which I probably won't get to till tomorrow, but it doesn't really matter, that has this kind of written out and has little places you fill stuff in. But just kind of stick with me for a little bit. All right, so we're going to talk about a few slides, and then we'll come back to this if we're not already out on the grass. Okay. We will use the process of distillation in our lab. We are not going to set up a real fancy thing. We're just going to let water evaporate over the weekend. Pretty hardcore, right? But it is distillation. I don't need to collect water. I need to collect the stuff that would be left after the water evaporates. Okay with that? All right. So distillation is separating homogeneous mixture on the basis of different boiling points. All right? We'll look cute right there. So the boiling point of water is 100 degrees, It's not going to get that hot in this room, but we do know that we have evaporation happen. And you'll learn about that in chapter 13, like why it happens. But then the stuff in the water, it's a solid. It doesn't really evaporate. So it'll be left after the weekend. All right? Filtration is also something we're going to use. Whatever. Filtration separates solid substances from liquids and solutions based on their solubility. If something dissolves, it will go through filter paper. If it doesn't dissolve, then it would stay in the filter paper. Okay? So we're going to use a magnet, a physical process. We're going to use filtration, a physical process. And we're going to use distillation, which for us we're going to call it evaporation, a physical process, to separate these four things into three separate groups. All right. The next one, I'll come back to that in a second. Well, I didn't realize I put those slides out of order, but it's not that big a deal. The last one we do not really use at all in this class is called chromatography. It also separates things based on their solubility and really their size. You use this in medical forensics, maybe biology. This is just a little spot of marker. You put that on filter paper. Then you put that in a solvent. That solvent travels up the filter paper or chromatography paper. They're actually the same thing pretty much. And over time, it separates into what it's made out of. So this black marker was made out of purple, yellow, some green, and some blue. The way this helps you separate, the largest molecules are at the bottom, the smallest are at the top. That's just based on gravity. It's harder to move the big ones up and easier to remove the small ones. We're okay with that? Okay. I have 2 minutes to talk about flowcharts. Flowcharts are not in your book, but they are something that we use a lot. A flowchart asks yes or no questions to separate things or to classify things into different groups. So, a basic flowchart we would use in this class to classify the students in this class. I need a yes or no question that could divide us roughly in half. What can we start with? All right. Are you a boy? Then, over here, what's another yes or no question I could use to separate the boys? Hair color? All right. Blonde. So this box, if I was going to not ask any more questions, I would put all the blonde males, right? And over here, I would put all the non-blonde males. Easy enough so far? All right, I could ask another question. What do we know about everyone on this side? They're a female so far, right? We could ask if they're tall or something. Like, we would need to be more specific. How about like 5'8" or taller? All right, like we could ask whatever we wanted. And we could get as detailed as we wanted. We don't need to get super detailed in the flowchart we're going to make for this lab. We're going to separate 4 things, and here's your last thing you're probably going to learn today. In a flowchart, you always ask one less question than the things you're going to separate. So if we separate 4 things, how many total questions do we need? Just 3. You okay with that? Okay, I'm pretty sure we're 20 seconds away from a fire drill. We'll see. Okay, so that was a pretty fun fire alarm. They enjoyed it. Okay, up here, last hour I asked them to do a flow chart to separate sand, charcoal, and water, which you did in regular chemistry in a homework problem. So we came up with a flow chart like if it floats. And a lot of times we want to make a flow chart that's actually usable. Like if you do these steps, you could actually separate things. So the first one, could it float? Because charcoal will float on water. And then we said we would like skim it off with some sort of net. Kind of all right with that? All right. There you go. There you go. That would work. I never thought about the overflow method. So that would get rid of the charcoal. Then we're left with sand and water, and that is easy. We said, will it stay in a filter if we pour it through? And sand does, water goes through, right? So now you have your three things separate. If you were required to find like their mass, like you will do in the lab, you're set. All right. One key, especially for the lab we're going to do, I don't know if it's down here. There you go. When you do a flow chart, do not have two yeses. If you have two yeses, meaning like, no, what I mean is, oops, whatever. I did this. It doesn't matter. Let's say we did the same thing, and I said, will it stay in a filter? And that's the first step I did. I now have not chalk. I still have gravel and charcoal in the filter. Now how do I separate those? Does that make sense? I want one thing separated in an easy, organized manner. When we do the actual lab, it'll make sense on why I said that. Because if we're going to do it in one day, you have to go in the right order, or you'll have to come back in like 3 or 4 days and do the second step. You all right with that? Okay. I'll print this. I didn't think we would get to it, so I didn't really plan on it. All right. So we'll run out of time, but tonight, if you haven't read yet, read those first 3 or 4 sections. And then if you haven't done the Ed puzzles yet, do those. On the Ed puzzle, you link to it through Canvas, you don't have to submit anything in Canvas. I will just grade it in Ed puzzle. What? That's up to you. I would just highlight, and you can draw in your book all you want. Yeah. 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 If you got lucky, you picked a book that was already highlighted and had notes in it. All you're doing is making it more valuable for the future. I have no problem with that. Now, don't write, this class sucks. I already know that. Yeah, please. Right now, you should be through sections 1.1 to 1.3, 1.4-ish.